Okay, so here we are continuing. This is video number 3 of the 7-part series. This is based on the Big M, which is the Florida B.E.S.T instructional guide that the Florida Department of Education puts out. These are the standards that we are covering here, and then these are some sample questions that are from this guide. So the first sample question, it says a triangle whose vertices are located at these 3 points is shifted to the right 2 units. So when something's shifted to the right 2 units, it's going to be, the transformation rule would be x plus 2. So you're adding to the x value, and then y will just stay the same. So we're going to add 2 to the x values here. So these fractions, of course, not ideal, but it is what it is. So I'm going to do 2/7 plus 2 over 1, and then create a common denominator here, and I get 2 over 7 plus 14 over 7, which is 16/7. So down here, the coordinates for 2/7 would then become 16/7, and then the y coordinate just stays the same. Okay, and then for the next set of coordinates, just add 2 to the -4 would be -2, and then the y coordinate again stays the same. And then for the third, we would get 5, 1. Okay, and moving on to the next page. The triangles whose vertices are located here is shifted up 3 units. So in this case, the transformation rule, x would stay the same, and we add 3 to the y value. So we're going to add 3 here, add 3 here, and add 3 here. So for this, the x will stay the same at 2/7, and then -1 plus 3 would be 2. X stays the same here, -4, and we have adding fractions again, so I will go ahead and do that here. You could also use your calculator to add fractions if that's a little bit easier, changing it into a common denominator. I get 1/5. So -4 and 1/5 for this coordinate, and then x stays the same for this one, and adding 3 would give me 4. Okay, on to the next question. In this case, which of the following correctly describes the translation slated here? Let me adjust my lighting a little bit. Okay. A triangle whose vertices are located here is shifted to the right 2 units. So here they're just looking for the rule. Shifted to the right 2 units would be x plus 2, and then y stays the same. So that would be this one right here. Okay, and then the next one. Which of the following correctly describes the translation here? Shifted down 3 units into the right 5. So x, y, down 3 units would be -3 to the y, and to the right 5 would be +5. So we're going to have x plus 5, y minus 3, and that's what I'm looking for. It's this one. Okay, choose all the transformations below that can be used when it's important to preserve angle measure. Preserve angle measure means that the angles wouldn't change. So if something is translated to a new spot, the angles wouldn't change. Likewise, if something is dilated, a dilated shape would be similar to the original and would have the same angles. So we're looking for anything like that. So rotation changes, location doesn't change angle measures. Vertical translation, it does preserve the angle measure. Reflection preserves the angle measure. Dilation, yes, like I said, even though they're changing size, they're similar and their angles are staying the same. Distortions, that would change the angle measure. So a distortion might be like a stretch of some kind, like this, and yeah, the angle measures would change. And then horizontal translation, stay the same, angles stay the same. Okay, next.
The time is now 2:30.
Okay, so on the next page, choose all the transformations below that can be used when it's important to preserve distance. Preserve distance. So clockwise rotation, changing location, but distance and the size of the shape is the same, so it preserves distance. Flexion preserves distance. Dilation would not preserve distance. Clockwise rotation, yes. Dilation, no. And then these two. So dilations are the ones that don't preserve distance. And this one right here, a single rotation map quadrilateral ABCD and 2 ABCD prime. So it's going from here to here. What is the center of rotation? So this right here is the center of rotation. Center of rotation is B. So it's being rotated like this. Next one, if the rotation is counterclockwise, how many degrees is the rotation? So counterclockwise rotation would be this way. It's one turn, so that would be a 90-degree rotation. And then a single rotation mapped quadrilateral, this onto this. Again, same picture. Describe another transformation that maps this onto the quadrilateral ABCD prime. A reflection across the line x equals what? So a reflection right here, and this is at x equals 1. There's a 1 right there. So that is at x equals 1. Next. Okay, for this one, it says perform the following sequence of transformations on the polygon. Rotate it 180 degrees counterclockwise. So the coordinate rules for that, for 180-degree rotation, xy becomes negative x, negative y. Then translate horizontally 2 units to the left and vertically down. So 2 units to the left would be x minus 2, and vertically down y minus 3. Okay, so A, right here, the points there are at -5, -1, and then after the 180-degree rotation, I would have +5, +1, change sign, and then subtract 2, subtract 3, we get 3, -2. So that is our answer, 3, -2 as the coordinates. Okay, next one. Similar problem, but now we're talking about point B right here, and B is at -3, -1. And again, for 180-degree rotation, xy becomes negative x, negative y. And then 2 units to the left, so it'd be -2, x minus 2, y minus 3. So change the sign here, we'd get 3, 1. Subtract 2 from the x and subtract 3 from the y, we get 1, -2. Next one, again, similar problem. Point C this time is at -2, -2. For the 180-degree rotation, it'll change sign, positive sign, and then 2 to the left would be -2, 3 down, 0, -1. And here, it wants to know about the rule here. Well, for 180 degrees, remember x, y becomes negative x, y, negative y, and then 2 to the left, so that'd be x minus 2 to go 2 to the left, and then vertically 3 units down, y minus 3, so it would be negative x minus 2 and negative y minus 3 would put them together. So this is what I'm looking for in the answer choices, and it's right here. Next one. Draw the resulting figure after quadrilateral ABCD is transformed using this rule. So I know it kind of continues over here, so it's negative x and then y minus 3. So it's talking about point A right here, which is at, I know the copy is not that great, A is at 2, this is actually 2 here, and this is a 4. So A is at 2, 4, and so that would become A prime would be at -2, 4 minus 3 would be 1. So we get -2, 1. This one right here, quadrilateral, is talking about point D, which is right here, and D is at 2, 0. So again, negative x and then y minus 3. So this would be -2. Oh, I did that backwards. Ooh, okay. D is at 0, 2. And then negative, there's no such thing as -0, it just stays 0. And then 2 minus 3 is -1. So we'd get 0, -1. And the last one for this video, draw the resulting figure after quadrilateral right here. So same thing, we're using the same rule, negative x, y minus 3. And we're talking about point B right here, which B is at 4, 2. So B prime would then be -4, 2 minus 3 would be -1. So -4, -1, and that is all. I'll have video number 4 linked below, and just click on that video to see the next set of problems.